In December 2016, a bombshell revelation rocked the world of classified intelligence. WikiLeaks had released top-secret Pentagon documents exposing a hidden war between the US Air Force and unidentified flying objects. According to these explosive files, the center of this interstellar conflict was none other than Antarctica, Earth's most remote and enigmatic continent. During the summer of 2016, the US Missile Defense System detected an entire fleet of UFOs rising from the Southern Ocean and heading at high speed toward the Mexican coast. American fighter jets were immediately scrambled, but just as suddenly as they appeared, the mysterious objects vanished from radar, leaving behind only questions and ripples of fear in high-ranking circles. And this, insiders claimed, was only one of many such encounters in a long-running, covert battle beneath the ice. The story spread like wildfire across forums, alternative news sites, and YouTube channels. Eyewitnesses reported that the surfacing UFOs created enormous waves, damaging ships in the area. Other reports spoke of alien bases discovered deep beneath Antarctic ice, with entire zones marked off-limits to the public. Some even claimed that Russian President Vladimir Putin was being briefed on secret skirmishes between US forces and non-human entities. The truth seemed ready to explode into public view. But how much of this is real? And did WikiLeaks actually publish such world-shattering documents? Since 2010, WikiLeaks has indeed released hundreds of thousands of files, diplomatic cables, military reports, and surveillance data. While some documents reference unusual aerial phenomena, none mention extraterrestrial conflict in Antarctica. The story's origin can be traced to a post on European Times, a dubious website known for spreading unverified claims. It cited anonymous Russian intelligence officers as the source. From there, the tale snowballed through conspiracy blogs that forged fake scans of supposed US documents, complete with seals, signatures, and official stamps. Yet under closer examination, these documents crumble. Fonts are inconsistent with military formatting. Signatures are copy-pasted from unrelated sources, and crucially, no corroborating evidence exists. Why did this theory stick? Despite its shaky foundation, the story refuses to die. Why? 1. Real secrecy in Antarctica. The continent is governed by strict international treaties. Military activity is restricted, creating a veil of mystery that invites speculation. 2. Historical myths. Tales of Nazi bases, ancient alien ruins, and lost civilizations buried under Antarctic ice have long fueled the imaginations of conspiracy theorists. 3. Real UFO sightings. The US military has confirmed encounters with unidentified aerial phenomena, such as the famous 2004 Tic Tac incident, adding legitimacy to UFO narratives. 4. The WikiLeaks halo. For many, anything associated with WikiLeaks automatically seems credible. That association lent weight to the fabricated documents. Antarctica's vast, silent expanse is a fertile ground for myth-making. From secret bases to wormholes, the continent has become a canvas for every kind of fantastical speculation. Even real locations like Lake Vostok, a subglacial lake Russian scientists spent decades drilling into, have been dragged into alien lore despite zero scientific evidence. Unusual military flights near Antarctica in 2016 and 2017, including Boeing RC-135 reconnaissance planes, added fuel to the fire. Officials cited training and climate research, but to believers, they were part of a hidden campaign against otherworldly threats. The tale of a secret UFO war exposed by WikiLeaks is thrilling, but ultimately, it doesn't hold up. There's no credible documentation, no trustworthy sources, and no confirmation from WikiLeaks itself. Like many conspiracy theories, this one blends fragments of truth with layers of fiction, creating a narrative too seductive to let go. But seductive isn't the same as true. Behind the allure lies a stark reality. No aliens, no Antarctic war, just another myth, thriving in the shadows of secrecy and our eternal hunger for the extraordinary. Still, as long as Antarctica stays silent, the legends will grow. because nothing feeds the imagination like a blank, frozen slate at the edge of the world.
Make a choice. 2 pills. One red, one blue. Take the blue pill and nothing changes. Take the red pill and you will see the world as it really is. A simulation. Yep, that's the plot of The Matrix. But the idea that we are living in a virtual world might actually be true. And the best part is, you can break free from it. Scientists call it the simulation hypothesis. Everything you see, feel, and experience might be part of a super detailed high-tech computer system. From your heart racing when you meet the love of your life to that fancy car you've always dreamed of, none of it is real. Let's say this theory is correct. How would it work? There are essentially 2 types of virtual worlds we could be trapped in. First, we have owned simulations. There is a clear central commander, like a game master, pulling the strings of everything we experience. Think of it as a video game. In this case, you are like an avatar from The Sims and someone's controlling your world. This higher being picks your job, decides when you need to go to the bathroom, and might even start a fire in your kitchen, just for fun. Okay, maybe fun isn't the best word, as it's more like sociological research. This super intelligent creature might have created a simulation to see how human history unfolds. They might be testing different events with different starting points, just to see what happens and how we, and other creatures of our planet, face different challenges. For example, this time they tried putting dinosaurs on the planet to deal with that huge meteor impact. Turns out, they didn't. All they want to do is test the problem-solving skills of humankind. That might explain why they didn't put us in a 100% happy, perfect virtual world. Okay, but who are they? Who is controlling our simulation? It could be some transcendental being, something beyond our ability to comprehend. Or it could be extraterrestrials. If one galactic civilization figured out how to create a high-fidelity simulation, they could make billions of virtual civilizations. Each of those could have trillions of beings. All they would need is more powerful computers. In fact, this may explain why we have never made contact with any extraterrestrials, even though there are probably 36 other civilizations out there in the Milky Way. If we are living in a simulation controlled by cosmic beings, we won't be able to see or contact them, unless they want us to. Our great architect could also be a super advanced AI, like a control freak version of ChatGPT. And that brings us to the second type of virtual world we could be trapped in: hostless simulations. These run without a boss, just like AI-generated stories. In this case, the creator is gone, but the simulated world keeps going on its own. Think of Star Wars Galaxies, for example. This game, based on the world-famous franchise, came out back in 2003. It was an open-world multiplayer game, which meant you could freely explore a huge, interactive map without being forced to follow a strict path. But its servers were shut down in 2011. That wasn't the end of it, though. A few loyal fans still play it on private servers. The problem is that developers stopped updating it, and without anyone keeping an eye on what players are doing, it opens the door for more glitches. Things that go beyond what the game was originally designed for, and definitely shouldn't be there. But the game is still running. Now, apply this Star Wars Galaxies situation to our reality. In the hostless simulations theory, the universe is a mess and humans are a glitch. Instead of being purposefully created, our consciousness and existence might have just emerged by a technical accident. So we might be nothing else but a bug in the code, like anomalies stuck inside a simulation with no owner, running on autopilot. But that can lead to a doomsday scenario. If the simulation gets overwhelmed with glitches, it could eventually collapse. See, the more we learn, the worse it gets. Our cultural and intellectual evolution might trigger a game over or a frozen screen because the owner of the simulation, whoever they are, might not want us to figure things out. They could reset the system or get rid of the source of the glitch, which, by the way, could be humanity itself. That's kind of like the Final Fantasy XIV situation. The game was originally released in 2010, but it was a mess. Players ran into all kinds of bugs and technical issues. Things got so bad that the game was shut down, and the developers decided to rebuild it. Then they released a new and improved version called A Realm Reborn. And a rebirth might be exactly what's in store for us. In fact, about 100 years from now, we might create an AI capable of running simulations of all humanity. It would use data from internet archives, DNA samples, photos, videos, and so on. This means that everyone who ever lived on Earth could be recreated in a virtual world, and in some sense, be born again. The problem, though, is that we don't have perfect knowledge of the past, especially the more distant times, so the simulation might not be 100% accurate. Whether our universe is controlled by some higher architect or the random powers of a super advanced AI, some experts believe that, yes, it is possible. Here are a few ways we might be able to hack the simulation. Hack number 1. Start by exploring the illusion. Look for its rules or flaws, and check for weird patterns or things like déjà vu that might point to its hidden structure. Hack number 2. Overload the system with massive amounts of data. This could eventually cause errors and push the limits of the simulation. Hack number 3. Crash the whole system by making everyone aware of it, for example. At some point, the simulation either shows its true form or just shuts down completely. The whole idea that we're living in a virtual world is definitely fascinating, but is it real? Let's talk numbers. Some scientists believe there is a 50-50 chance that Earth is a simulation, but the odds might be actually much higher than that, because there are an infinite number of potential simulated worlds. And inside each one of them, there are simulated people who have created even more simulated worlds. So, mathematically speaking, the chances of finding yourself in the one true physical world are almost zero. Although it is really hard to prove it, some experts believe that evidence is everywhere. It could be as simple as feeling a déjà vu. You know, that strange feeling when you think you've experienced something before, even though it's happening for the first time. That could actually be cracks or temporary flaws in virtual reality. Another possible evidence is what is known as the Mandela effect. This is when a large group of people remember something differently than how it actually happened, like a shared false memory. For example, a lot of people remember the iconic "Luke, I am your father" from Star Wars. But what Darth Vader actually said was, "No, I am your father." For some people, this is enough evidence to prove we are part of a simulation. And while we haven't found the red pill just yet, we now know it's not impossible to crack the code. So it might not be a bad idea to let Keanu Reeves know about this, just in case.
NASA is on the hunt for Dyson spheres. Turns out there are 60 stars that give off weird light patterns. This means there might be some extraterrestrial technology nearby. A team of scientists has developed a new way to search for advanced civilizations by looking for Dyson spheres. All forms of life, from microbes to us, need energy in order to survive. As living creatures keep evolving, their energy needs grow. We started with small fires, then moved on to coal, oil, and eventually solar panels. Now imagine a super advanced civilization that has used up all the energy sources on its planet. What's next? Their host star, an almost limitless power source. This is where the idea of Dyson spheres comes in. It was made up by the physicist Freeman Dyson in the 1960s. This idea says that, hypothetically, we could build an incredibly big structure around a star to capture its energy, like some sort of gigantic solar panel. Advanced civilizations could use it to power their planet and even interstellar travel. Right now, something like this would be impossible for us to build, but maybe someone else in the universe has managed to pull that off. Scientists gathered lots of data from surveys of stars. They analyzed over 5 million objects and found some candidates. Of course, extraterrestrial civilizations might have completely different technology, so astronomers aren't looking for actual giant shells around stars. Instead, they're looking for technosignatures. These are weird things that might indicate the presence of something technological and can't be explained by known natural sources like galaxies or nebula. For example, a structure like a Dyson sphere could give off unusual infrared radiation. This is because, while absorbing a star's energy, this structure would give off crazy amounts of heat. Out of millions, they identified 368 potential candidates. Further filtering left them with only 7 objects that could be Dyson spheres. Now, usually, weird infrared flickering happens from giant crashes in space, like planetary collisions. Warmed-up dust and rocks get scattered around and give off strange lighting patterns. These are called extreme debris disks. The researchers think these 7 objects could be M-type stars, also called red dwarfs. These are stars that are very small on the space scale and a bit fainter than our Sun, a yellow dwarf. Stars like that don't usually have warm dust and rocks around them, but scientists need to do more tests, like looking at the light in detail, to be sure about their discovery. There was another study that found 53 star candidates with similar excess infrared radiation. But these also need to be checked. Scientists plan to use advanced tools like the James Webb Space Telescope to take a closer look at all these candidates. One famous candidate is Tabby's star. Scientists even made a joking name for it because the paper about this star had the subtitle, "Where's the Flux?" Think of an acronym yourself. Now, it's a bit hotter and more massive than our Sun. It's caught NASA's attention because of its unusual, irregular light dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turns on and off a flashlight. At first, you might think this is just because some big planet is passing in front of it, or a comet, but we're talking up to a 22% drop in light. No planet could manage to eclipse a quarter of a star, and that's where the name comes in. So, another explanation is a Dyson sphere or some similar megastructure. Someone also suggested that the dips might be caused by fragments from a broken exomoon orbiting the star. There are other stars that show similar traits, but there's no solid evidence to support this. So for now, scientists just don't know. So astronomers are on the hunt for any giant structures. There are many variations of what a Dyson sphere could look like: rings, bubbles, a swarm of satellites, a giant shell, and so on. A Dyson shell would be a solid, rigid shell completely enclosing the star. This is the most extreme option, the hardest one to build. Also, if other civilizations built that thing, it would fully cover the star's light, and we simply wouldn't see it. The inner surface of this shell could be lined with habitats, and we could simulate gravity by rotating the structure around the Sun. A Dyson swarm is the simplest option, a bunch of solar-collecting satellites and habitats orbiting the star. It would be a lovely place, with people living in many space stations or mini space houses within the swarm. Each little habitat would have its own air, life support systems, and artificial gravity. We could also grow our little farms there. And imagine the view. We would see a constant bright sky with other habitats visible across the expanse. A near unlimited energy of a star would mean we could advance our technology very fast, manufacture tons of materials, and terraform planets within the star system. But building and maintaining a Dyson sphere would require advanced robotics, AI, and tons of money. It would take us centuries or millennia to get there. Now, giant megastructures aren't the only things that scientists are looking for in order to find extraterrestrial life. They also look at the planets. Now, planets must have certain characteristics to be potential homes. There should be liquid water and an energy source, something to drive these reactions, creating the building blocks of life. Turns out such conditions aren't rare at all. Our search showed that there might be more than 60 billion potential habitable planets in the Milky Way alone. Unfortunately, we can't look at them directly or land there. So we have to use tricks, like detecting water and good gases in their atmosphere. Recently, the James Webb Space Telescope found possible signs of life on a planet called K218b, which is pretty close, about 120 light-years from Earth. This planet is 9 times the size of Earth. It has clouds of liquid water but a different atmosphere, full of gases like methane, carbon dioxide, and dimethyl sulfide. Regular oxygen-breathing life wouldn't do well at all there, but on Earth, dimethyl sulfide is produced by life forms like phytoplankton. They also discovered that weird wiggly planets could be signs of advanced extraterrestrial civilizations. In our solar system, each planet has its own orbit. But the universe likes to surprise us. Surprise! Models show that there might be planets that share the same orbit. For example, it's possible if the planets are evenly spaced around the star, minimizing their gravitational impact on each other. Or the so-called horseshoe configuration, when planets speed up and slow down in relation to each other, moving in funny wiggly ways. These horseshoe systems can hold up to 24 planets. This is one of those things that are possible but very unlikely without some help. Normally, gravity would immediately destabilize such systems. This means that if we ever find a star system with 24 planets sharing orbits, it might indicate that some advanced civilization decided to lend a hand. They also might contact us themselves. The search for extraterrestrial intelligence began in the 1960s when astronomer Frank Drake started listening for radio signals from space. Today, they persist. Astronomers listen for leakage radiation from other civilizations, which are radio waves unintentionally sent into space from everyday activities. Recently, they detected radio waves from YZ Ceti b, a planet super close to us, just 12 light-years away. This means it might have a magnetic field, invisible shields that are very important for protecting life from the solar radiation. But YZ Ceti b is probably too close to its star to be habitable. But there are a lot of places for such a signal to come from. It turns out there are 1,000 star systems in our galaxy where they can see us in the sky. All these stars have a perfect view of Earth passing in front of the Sun, making it easy for potential extraterrestrial astronomers to spot us. So, there are over 1,000 star systems that could be watching us right now. And if we study them, we might one day find evidence of intelligent life looking back at us. Hello!
Turns out we have some ways to solve the time travel paradoxes. Time travel sounds enticing, but brings with us a lot of problems. Take, for example, the famous grandfather paradox. Imagine that you travel back in time and prevent your grandparents from meeting. This alters the course of history. But how? If you erase their encounter, you cease to exist, so you couldn't even travel back in time to alter the past in the first place. There's also the bootstrap paradox. Let's say we travel back in time and give Beethoven his own compositions before he ever penned them. He gets famous for the very music you provided. But where did it originate? Did you start it? Or was it Beethoven who started it? There are many theories about time travel. One of them involves alternate timelines and parallel universes, like in Back to the Future, for example. If parallel worlds exist, we could hypothetically travel in one where the events unfolded differently, while our original timeline stays the same. This is a beautiful and paradox-free approach, but this is pure sci-fi, as we have no concrete evidence of parallel universes. So what scientists are trying to do instead is to figure out whether time travel is impossible in this one universal timeline. We've been exploring this equation for over a decade and created a fascinating concept called a closed time-like curve, or CTC. Imagine taking a path that forms a loop, bringing it back to where it started, but in time. We know that space-time is like a wobbly piece of cloth which can curve and bend when we place heavy objects on it. In some situations, like near massive objects such as stars or black holes, space-time can be curved. Now, imagine an object that's so heavy, with gravity curving the space-time so strongly that it literally loops on itself. If this idea turns out to be real, it could suggest the possibility of traveling back in time in our world line. This possibility is fascinating, but it also creates tons of problems, and scientists may have found the ways to solve them. One of the solutions is that doing paradoxical things can be simply impossible. In this scenario, we assume that the universe has some mechanisms of self-consistency. It means that while you can still travel in time, you're restricted in the actions you can take. For example, you may not be able to go back and alter your family's history, but there's nothing inherently illogical about traveling back in time to simply interact with your ancestors. In this scenario, the universe only forbids you to do logically impossible things. Scientists decided to conduct an experiment to check if it works, and the results were pretty terrifying. The experiment conducted involved the creation of a theoretical time machine. This is also called an in-principle time machine. This wasn't a physical device, but rather a quantum simulation. In the simulation, they attempted to send a photon back in time by a fraction of a second and make it interact with its past self. The goal was to find out what the photon will do. Will it destroy its previous self, avoid the interaction, or something else? What happened is that as the photon approached its past self and was getting closer to the point of creating a paradox, the experiment tended to fail more frequently. In other words, it seems like the laws of physics or the fabric of the universe might have some weird built-in mechanisms that prevent time travel paradoxes. In that case, the question is, how does the universe understand what is logically impossible? And how does it prevent us from doing these things? Which is quite scary to think about. There's another theory that the universe allows paradoxical things to happen, but also self-corrects them. Imagine a time traveler going back to stop some health condition from spreading. According to this theory, even if the traveler succeeds, this health condition would find another way to spread, avoiding the paradox. Or maybe we all exist in time loops. These loops allow objects to interact with their past selves while still maintaining a consistent timeline, because there's no beginning point. For example, trying to prevent a historical event could result in accidentally catalyzing the event we were trying to prevent. This idea challenges our understanding of classical physics and free will. But all these ideas are purely theoretical, and to test them, we first need to find the mechanism to actually travel back in time. Talking about practical time travel, we mentioned that space-time curves around very heavy objects. Does it mean that black holes can be portals to the past and the future? Maybe. Black holes are formed when a massive star collapses inward. Their gravitational pull is so intense that even light can't escape. This means they're perfect for bending not just space, but even time itself. You might remember this from Interstellar. Near a black hole, time slows down. This effect is so pronounced that a year near a black hole could translate to decades on Earth. In that case, traveling back to the past using a black hole is theoretically possible. If their gravity twists time so much that it wraps back on itself, creating a closed time-like curve, and you could enter this loop, you'd find yourself on a journey from the future to the past. But there are some problems with this. First, you can only travel into the black hole's past. Second, to enter the loop, you'd likely have to cross the event horizon, the point of no return around a black hole. To escape one, you'd have to travel faster than light, which is currently impossible. So, while black holes might hold the keys to time travel, the journey inside one might be your last. But not everyone agrees that closed time-like curves exist at all. Recent research has shed new light on this topic. The results showed that time can only move forward. The research offered a fresh perspective on how light behaves when it encounters different materials. When light moves through empty space, it travels at a constant speed of 186,000 miles per second. But when it encounters substances like water or glass, its speed can change, causing it to bend or refract. While scientists have equations to describe this behavior, they struggled with the problem of the change of the speed of light at the boundary in different mediums. Well, researchers proposed a solution to this puzzle by reconsidering how light moves through time and space. They figured out that it always remains constant as it travels through different mediums. No matter what the light encounters, it always moves forward in time. This means that light and other waves like it follow the same one-way path through time that we do. Another thing is that light also always saves its momentum, and it always stays the same, pointing forward in time. And finally, even with general relativity and with gravity bending light very strongly, it still keeps pointing forward. It can slow down to the point of feeling like time stopped, but never move backwards. This challenges our previous notions about the relationship between light and time. It implies that time has a definite direction for all waves, making it impossible to reverse. However, their equations have only been tested in one dimension, and experiments are needed to confirm if this theory holds true in reality. Stephen Hawking also disagreed with the idea of traveling back in time. He proposed a theory called the chronology protection conjecture. This idea says that the laws of physics stop time travel on large scales, even when theories like general relativity say it's possible, and that closed time-like curves simply can't exist. Hawking said that traveling back in time would mean creating new matter, which goes against the laws of physics. Although we're far from building actual time machines, if we keep diving into mathematics, we might find the truth one day.
The moon has always been a source of wonder, myth, and mystery. It lights up our nights, controls the tides, and marks the rhythms of time. But what if the moon isn't what it seems? What if this familiar, glowing orb in the sky is not a natural object at all, but a hollow, perhaps even artificial construct? That's the central idea behind the hollow moon theory, a concept that blends science fiction with ancient lore and dares to question everything we think we know about Earth's closest celestial neighbor. Let's explore the bizarre clues and strange stories that fuel this unsettling possibility. During the Apollo missions in the late 1960s and early 1970s, NASA astronauts left behind scientific instruments, including seismometers. In 1969, the Apollo 12 crew intentionally crashed a portion of their spacecraft onto the lunar surface. The result shocked mission control. The moon reverberated for over 50 minutes. Scientists said it rang like a bell. This was not a one-time event. Later impacts during Apollo 13 and 14 produced similar results, long-lasting, deep seismic vibrations that were unlike anything observed on Earth. Some theorists argue that this behavior could be a sign that the moon is hollow or has vast inner cavities. After all, nothing on Earth behaves that way unless it's mostly empty inside. NASA's explanation is more conservative. The moon has a dry, rigid crust with little water content, which allows seismic waves to travel much farther than they would through Earth's moist, fractured interior. Still, the Bell effect remains one of the strangest lunar anomalies on record. In many ancient cultures, there are legends of a time when there was no moon. Aristotle mentioned that the Pelasgians, the ancient people of Arcadia, lived before there was a moon in the heavens. The Zulu people of Africa tell stories of two brothers, Wawane and Mpanku, who brought the moon to Earth, an artificial object, hollow and controlled, which changed the weather and caused great floods. Ancient Sumerian texts also hint at a celestial object that arrived unexpectedly in the sky. These accounts span multiple continents and civilizations, alluding to a world that once turned without a moon. Are these myths simply poetic metaphors? Or could they be distant memories of real events passed down in the only language available to ancient humans, myth and story? The moon is the fifth largest natural satellite in the solar system, and by far the largest relative to the size of its planet. No other moon comes close in size ratio. This alone makes Earth's moon an outlier, but there's more. The moon is precisely the right distance from Earth, about 384,000 kilometers, to perfectly cover the sun during a total solar eclipse. The sun is 400 times larger than the moon, and also about 400 times farther away. This perfect 400 to 400 ratio creates an extraordinary visual phenomenon that allows scientists to study the sun's corona during eclipses. Coincidence? Maybe. But to some researchers, it feels more like design. And then there's the moon's orbit. It's almost perfectly circular, and it's tidally locked, meaning we always see the same face. We never see the far side of the moon from Earth, unless we send spacecraft around it. Why does this object behave so precisely? Is it a natural product of gravitational forces, or something else? In 1970, Soviet scientists Mikhail Vasin and Alexander Sherbakov published a radical paper titled, "Is the Moon the Creation of Alien Intelligence?" They suggested that the moon may be a colossal, ancient spaceship, an alien construct disguised as a natural satellite. According to their hypothesis, the moon might have a metallic outer shell with an inner structure that once supported machinery, life, or monitoring equipment. They compared it to a planet-sized arc that could travel between star systems. While their paper was largely dismissed in the West, it planted the seed for countless other theories. Could the moon be a derelict alien spacecraft? Long abandoned, perhaps watching us still? More recent fringe thinkers have proposed even stranger ideas. Some argue that the moon might not just be a passive structure, but a kind of anchor for a simulated or controlled reality. In this vision, the moon is not just hollow, but alive with technology, possibly operating as a monitoring station, memory regulator, or even a civilization reset button. Ancient floods, magnetic pole shifts, and unexplained disasters. Some theorists claim these events correlate with specific lunar alignments or cycles. Others go further, suggesting that the moon is part of a larger system designed to keep human consciousness limited, trapped in cycles of forgetting and rediscovery. Is the moon helping to shape our very perception of time, reality, and evolution? It's impossible to prove, and perhaps that's the point. Even beyond the big theories, there are many small puzzles that don't quite fit. For example, when scientists first studied moon rocks, they expected to find thick layers of accumulated dust, possibly several meters deep. Instead, the moon's surface dust was surprisingly shallow. Where did all the debris go? Radio signals sent to the moon sometimes bounce back with strange delays, suggesting interior reflections that aren't typical for solid rock. And then there are the mysterious transient lunar phenomena. Sudden flashes, glows, or color changes on the moon's surface. These have been observed by astronomers for centuries, yet remain unexplained. Mainstream science sees the moon as the product of a massive collision in Earth's early history, a fragment of the young planet that cooled into orbit. But for every answer science provides, there seem to be more questions. Why does this object behave so perfectly? Why do myths around the world speak of its arrival? And why does its presence feel so scripted? Whether you believe in the hollow moon theory or not, one thing is certain: the moon is far more than just a rock in the sky. It is a mirror to our imagination, a beacon to our ancestors, and maybe, just maybe, a puzzle we were never meant to solve.
Warning: if you're a devoted fan of ETs and accept every story about contact with them as fact, you might want to skip this video. What you're about to hear is the hard truth, and yes, it may be disappointing. On the other hand, if the idea of them makes you uneasy, this video might actually put you at ease. And if you don't believe in those little green cuties but constantly find yourself debating people who do, just show them this. First, you need to know that there's no solid evidence that intelligent extraterrestrial life exists. What does exist is strong evidence that all the so-called ET incidents you've heard about during your whole life actually have very reasonable explanations. One of the most famous examples is the Roswell incident. On July 8, 1947, a strange object crashed on a ranch in the state of New Mexico. It was described as a flying disc. First, a local newspaper reported the story. Then, the incident spread across the entire country. People claimed it was the crash of an ET spacecraft. Authorities said the object was a meteorological balloon. People didn't believe them. Rumors exploded. Many theories spread everywhere. Years later, after all the hype slowed down, the truth finally came out. The flying disc was part of a top-secret government project, a high-altitude balloon designed to detect signs of nuclear testing. But even after the truth was revealed, many people refused to accept it. The Roswell incident became a full-blown cultural phenomenon, especially among UFO enthusiasts. Yet, among the thousands of books, articles, and documentaries about Roswell, you won't find a single verified fact proving an ET spacecraft was ever involved there. That same year, another mysterious object was discovered and also caught public attention. No one knows exactly where it landed, but many people connect it to the Roswell incident. At first glance, this metallic fragment seemed extraordinary. Its internal structure looked unlike anything known at the time, which led some to believe it was part of an alien craft. Further analysis showed the object was made from an alloy of magnesium and zinc, with traces of bismuth, lead, and other elements. Of course, the presence of these elements alone doesn't prove the object was made on Earth, since these substances exist throughout the universe. Then, scientists examined the isotopic composition of magnesium and the rest of the materials, and they determined that the alloy was manufactured on Earth. Still, one thing about the sample raised eyebrows: bismuth. Some people speculated that aliens might use bismuth in some kind of propulsion or flight system. However, these ideas were purely speculative. The bismuth found in the samples contained impurities, which clearly showed it was produced using ordinary Earth-based manufacturing methods, not any unknown technology. But that technology would require a pure bismuth alloy. Unfortunately for UFO fans, the analysis showed that the bismuth in the sample contained lead impurities, which is clear evidence that no alien technology was involved. It was created on Earth by people. However, its manufacturing process was unusual because of the specific mix of elements. The object also had damage caused by impact and heat exposure. Most likely, it was a component of another top-secret surveillance balloon. Okay, how about another alien-like incident? This is the famous but though less well-known WOW signal. In 1977, a radio telescope in Ohio detected a strange signal from deep space. It lasted 72 seconds and stood out dramatically from the background cosmic noise. Astronomer Jerry Amon, who discovered it, was so shocked that he wrote "Wow" on the printout. The scientific community briefly suspected that this radio signal might be a message from alien technology, but it was never detected again. Later explanations suggested it may have been radio emissions from a neutron star, amplified by a cold hydrogen cloud. You can also find realistic explanations for other similar cases on the internet. However, Roswell and similar cases happened decades ago. But what about modern stories? You've probably seen videos recorded by pilots showing fast-moving, elusive objects in the sky. Scientists carefully analyzed these videos and found something interesting. The observed behavior contradicted the laws of physics. If an object moved that fast through air or water, friction should produce a visible heat trail or plasma glow. But nothing like that appears in the footage. Does that mean it's alien technology? Probably not. A much simpler explanation is that the cameras used weren't advanced enough to capture what was actually happening. We don't know the distance between the object and the camera. We don't know its real speed. It could be a visual artifact, a sensor glitch, or a lens distortion. If you still believe these recordings show real UFOs, ask yourself this: why, after all these years, do we still have no high-quality footage? Why is it always low resolution, blurry, and often black and white? Millions of unclear images mean nothing compared to a single clear, high-resolution video, and we don't have one. The probability that UFO sightings are optical illusions or sensor errors is far higher than the probability that they represent alien spacecraft. Many people simply want to believe in ETs, so they amplify hype about any news hinting at extraterrestrial technology. A perfect example is Oumuamua, the first known object to enter our solar system from interstellar space. Some people panicked, claiming it was an alien probe. In reality, it was almost certainly an interstellar asteroid-like object. Remember the more recent panic surrounding 3I Atlas? Online rumors claimed it was an artificial object that would approach Earth in November 2025 and change our lives forever. November has passed, the object is now moving farther away. No alien invasion happened. So does that mean the only way to find extraterrestrial life is to wait for random space rocks to pass by? Or hope someone records a UFO in 4K, or 1080 at least? Can we actually do something ourselves? Yes, we can search for technosignatures. Technosignatures are signs of technological activity that intelligent life could do. These are biosignatures like microbes or molecules that suggest simple life. But searching for biosignatures across space is incredibly difficult. Technosignatures are easier. They include radio signals, laser emissions, or atmospheric pollutants such as carbon dioxide or methane. Earth itself emits technosignatures detectable from afar, so why not look for the same on other planets? Where do we start? There are over 6,000 known exoplanets. Any alien technology would be based on the same physics and chemistry as ours, because the laws of physics are universal. Maybe massive solar panels on a distant planet produce excess heat we can detect, or perhaps large-scale industry releases chemicals visible through powerful telescopes. There's a checklist of technosignatures scientists look for. When something matches the list, the real work begins. Researchers must confirm that the signal comes from technology, not a natural process in space. A few years ago, astronomers observed a Tabby's star, about 1,280 light-years away. Then, they noticed that it began to darken as some huge object blocked it. Its unusual dimming led to speculation about alien megastructures. They suggested it could be some giant alien ship that parked near the star. In reality, it was just space dust flying around. That's why every technosignature requires careful verification. However, so far, no confirmed technosignatures have been found. Space is vast, the planets are distant. Maybe we simply can't see each other yet. Even if there is intelligent life, our communication might be impossible with current technology for them and for us. One famous Italian-American physicist, Enrico Fermi, once summed this up with a simple question: where is everybody? No, how is it possible that no one in the whole cosmos has contacted us yet? Perhaps the most uncomfortable answer is the simplest one. Maybe we really are alone. Of course, there's a possibility that the aliens just don't want to get in touch with us, or they're still developing their technologies for interstellar connection. But let's be realistic. Aliens don't exist. Probably.
Well, the space object 3I Atlas just whipped past the sun, and instead of clearing things up, the new images made everything even stranger. Because if this thing really is a comet, then it's the strangest comet ever recorded. And if it's not a comet, then we're watching something completely new invade our solar system. So, should we be worried? This all started back in July 2025. Astronomers using the Atlas Survey telescope in Chile spotted a faint, super fast-moving object, something unlike anything they'd seen before. That was our first look at 3I Atlas, and right away, scientists had a lot of questions. Where did it come from? What's it made of? But more importantly, what is this thing? At first glance, it almost looks like a tiny cell, right? Like something you'd see under a microscope, with a bright center like a nucleus, and this fuzzy outer layer. But when we look at it from a different angle, the mystery clears up. That glow is actually a comet tail. It's precisely because it looks like and behaves like a comet that NASA finally confirmed it. Yup, 3I Atlas really is a comet. The big giveaway is that it has an icy nucleus and a coma, which is that glowing cloud of gas and dust surrounding it. But this comet is a very special one because it didn't come from our own solar system. It came from somewhere else in the Milky Way. And that's ridiculously rare. To give you an idea, we've only ever seen 3 objects like this, period. The first 2 interstellar visits were the famous Oumuamua and the comet Borisov. And now, 3I Atlas. Cool. But you might be asking, how do we know it actually came from outside our solar system? You see, normal comets are bound to the Sun. They swing around it in these big looping orbits. But 3I Atlas isn't doing that. Its crazy speed and path show it's not on a closed orbit around the Sun. And the only logical explanation is that it came from another star system and, just wandered into ours by chance. In other words, this is just a visitor passing through our solar system, and is doing it at a ridiculous speed. When we first spotted it, it was going around 137,000 miles per hour. So this object probably spent millions of years cruising through deep space just to hang around our solar system for a few months. And after this quick visit, it'll vanish into interstellar space, and we'll never see it again. Recently, 2 European Space Agency satellites, along with several NASA spacecraft near Mars, captured new images of 3I Atlas zooming in as it passed the red planet. And one of those images is pretty incredible, showing a cloud of hydrogen atoms around the comet. Scientists were pretty excited about that, as every bit of information we get from this visitor matters. Because the reality is, there are still a lot of unanswered questions about this object, starting with its size. We can't pin it down exactly yet, but NASA says it could be anywhere from about 1,400 feet to around 3.5 miles in diameter. Its exact shape is another mystery, because our telescopes can't really get a clear look at it. The nucleus is buried inside this bright coma of gas and dust, and the sunlight reflecting off all that dust basically blinds us. So for now, we're trying to see it through a bright, dusty fog. If you put all the pieces together, its behavior, its chemistry, and the images we've gotten so far, everything points to 3I Atlas being a comet. But even with all that, there are still some pretty controversial ideas floating around about what it might be. Not long after it was discovered, Harvard astrophysicist Avi Loeb said there's maybe a 30 to 40% chance this object isn't something naturally formed. That comment kicked off a wave of online buzz, with people jumping to wild possibilities. Like maybe it's some kind of extraterrestrial tech, or worse, a threat to Earth. Ooh. According to this theory, 3I Atlas might be a massive extraterrestrial mothership. Its odd trajectory could mean it's sending out little satellites toward Jupiter to collect intel for some extraterrestrial civilization. So, in that version of the story, this isn't just a comet. It's basically advanced space spy tech. But then the obvious question is, why spy on Jupiter, right? I mean, wouldn't Earth be way more interesting to an interstellar civilization? Well, in this theory, Jupiter is the target because it's so much bigger than Earth and the other neighboring planets. The idea that a planet that massive could act kind of as an interstellar beacon, something that stands out from far away. The region near Jupiter is another big reason. It's almost like it's an ideal parking spot, where space technology could basically hang out without using much fuel at all. In other words, if you were going to place advanced satellites somewhere to watch a planet, well, that's prime real estate. Pretty cool, huh? But as fun as that theory is, we gotta come back down to Earth for a second. According to the major space agencies, this thing is a comet, case closed. But that label doesn't make it any less special. 3I Atlas is still a total weirdo in the best way, and it stands out for a bunch of reasons. Let's look at 3 of the most important ones. First, this object is old, like really old. Older than me. Scientists think it's been traveling through space for at least 7 billion years. That's so far back in time that it was formed before our Sun and Earth even existed. So yeah, it's probably the most ancient thing we've ever seen in our cosmic neighborhood. Second, its glow. Comets can sometimes look kinda green, and here's why. When a comet gets closer to the Sun, the ice inside it heats up and starts releasing gas. I know the feeling. Some of that gas is made of carbon-based molecules, especially one called diatomic carbon, or C2. When sunlight hits those molecules, they light up, and to us, that glow shows up as green. But with 3I Atlas, that green color is, well, confusing. The data suggests that this comet is actually low on those carbon chain molecules. So, the big mystery is, if it doesn't have much C2, how is it glowing green at all? Well, nobody knows. And now, the third thing that makes this comet stand out. It seems to be giving off a metal alloy we've basically never seen in nature. So this comet is releasing a plume that contains nickel. That's normal. What's strange is what's missing: iron. In comets, nickel and iron usually show up in pretty similar amounts. Here, we're seeing nickel, but no clear sign of iron. And that's almost unheard of. If the data holds up, it points to an alloy called nickel tetracarbonyl, something we've only ever seen before in human-made industrial processes, not out in space. No other known object has shown this kind of signature. Well, now that you're familiar with 3I Atlas, we gotta answer the biggest question of all. Is it a threat to us? Good news! No, the comet isn't dangerous, and it's going to stay really far from Earth. So we can all take a deep breath. Well, I feel better. Although it's harmless, tracking it has been super valuable for planetary defense. You see, space agencies are always watching asteroids and comets, running the numbers on their orbits, and making sure we'd get a warning if something ever did head our way. But 3I Atlas gave them something new to practice with. This is the first time tracking data from spacecraft orbiting another planet were officially submitted to and accepted by the Minor Planet Center. That's the big global database where asteroid and comet observations get collected and checked, so scientists everywhere can stay on the same page. So, in a way, 3I Atlas was like a rehearsal. Gathering data like this from a totally new setup helps researchers sharpen their methods and improve how we spot future space objects. And that means better detection, faster tracking, and more readiness, just in case the next visitor isn't quite so friendly. Uh-oh. A large space probe is nearing the Sun. The terrifying heat of the star begins to melt the shell of the spacecraft. Another moment, and the probe bursts into flames. In no time, it disintegrates in a powerful explosion. Ah, what a sad ending. If it were true, it was not a probe. It was a comet known as 3I Atlas. And despite everything people say, it's still intact and thriving. The thing is, there is a rumor online saying that comet 3I Atlas exploded when it got closest to the Sun. But astronomers say this is not true. There was no explosion, and the comet's nucleus still looks whole and undamaged, which is kinda surprising, since comets that pass very close to the Sun usually go through some serious changes. You see, comets are made of a mix of ice, dust, and rocky material, which is why they're often called dirty snowballs. So, when they come close to the Sun, the intense heat from our star makes their ice turn into gas. This new gas can burst out in huge jets, form a cloud around the comet called a coma, and/or be pushed away into a long tail. Sunlight makes all of these parts shine more brightly, and even people with small or simple telescopes can study the comet if the viewing conditions are good. But aside from being a breathtaking view, such a close approach can break off pieces of a comet or even tear its whole nucleus apart. Now, it's true that some comets survive this process, but many, especially small ones, or comets entering the inner solar system for the first time, break into pieces or disappear completely. Well, 3I Atlas acted differently. So there. It reached its closest point to the Sun on October 29, 2025. This point is called the perihelion. At that moment, the comet was about 130 million miles from the Sun. That's about 1.5 times the distance between the Sun and our planet. The comet was also on the opposite side of the Sun from Earth, so the star was blocking it from our view and we couldn't see the comet. Anyway, even though 3I Atlas could hypothetically break apart or release lots of fragments, it didn't. The nucleus stayed intact, and this made the comet's behavior even more unusual and interesting to scientists. They looked closely at the new photos and said everything looked normal. Now, interestingly, the day before, some people thought the comet had broken into pieces after it came out from behind the far side of the Sun. This idea became popular after a blog post said the comet had lost a lot of mass. So, to make this claim, the blog used photos taken on November 9th by 2 small telescopes in Spain. The pictures show jets of gas coming out of the comet. The scientists used this to estimate how much material was coming off the comet, claiming that it should have broken into at least 16 pieces. However, many scientists have questioned this statement. Most researchers say there's no proof that the comet exploded. One scientist who studies the comet says that all the images he had seen showed a completely normal, healthy comet. There's no sign that the main body of the comet has broken apart. Still, now that the comet is coming back into view, astronomers are watching it very carefully. They want to learn more about the comet's materials and structure. Right now, if you look at it from Earth, the comet seems to be slowly moving higher in the eastern sky. If the weather is good, people in many parts of the northern hemisphere can see it with a small telescope, like this one with a 6-inch lens. And many do pay attention to the comet. Since it was discovered in July, it has become the center of many curious ideas. Some people are sure that the comet, which comes from outside our solar system and might be more than 7 billion years old, could be a probe sent by a different civilization. Now, most astronomers strongly disagree, of course. They believe the comet is completely natural and comes from another star system somewhere in the Milky Way. And this is actually exciting. Comet 3I Atlas is only the 3rd interstellar comet ever seen, and it is the largest one of its kind. Before, it was Comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But 3I Atlas, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which was just a 1/4 mile long, and Borisov, which is about 3/10 of a mile across. Plus, 3I Atlas may be the oldest comet humans have ever observed. Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. It was the first known object from another star system to pass through our solar system, basically our first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. As for 2I Borisov, it sits in between, at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma, a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the Sun. Plus, it also had a long tail of dust and gas. Now, 2I Borisov is speeding away from the Sun and will never return. But it allowed scientists to take a glimpse into the chemistry and history of distant worlds. Now, let's get back to Comet 3I Atlas. It will pass closest to Earth on December 19th. Until then, scientists will make many more observations. People will also make many new claims about the comet, that's for sure. But it's best to be cautious and not believe everything immediately. By the way, even though you can't see this famous comet with your own eyes or with a regular telescope, hey, that's good news. A powerful telescope in Italy is streaming it live for free. Whoa! So anyone can actually watch this mysterious object as it passes by. Scientists think this comet weighs about 33 billion tons. That's a big number. How about we make a few comparisons? The Eiffel Tower weighs around 10,000 tons. So, 33 billion tons is the same as 3.3 million Eiffel Towers. And if you decide to compare the space visitor to buildings, well, 33 billion tons is about the same as the weight of several huge city areas made entirely of steel and concrete. Now, 3I Atlas was first noticed in July by NASA's Asteroid Terrestrial Impact Last Alert System, which, if you're paying attention, is where they got the nickname Atlas. Shortly after, NASA confirmed that the object wasn't from our solar system at all. Now, besides being huge, 3I Atlas is unusual in several other ways. As it moves through the solar system, it's releasing massive amounts of carbon dioxide and dust. So this suggests that 3I Atlas is 3 to 5 orders of magnitude, which means 1,000 to 100,000 times more massive than the two other known interstellar visitors. Such an enormous difference is a real scientific mystery. It's also traveling incredibly fast, about 150,000 miles per hour, which is almost 200 times the speed of sound. Hey, that will get you a speeding ticket. And unlike objects in our solar system, which follow curved paths because of gravity, 3I Atlas is moving on a nearly straight line. That alone makes it stand out. Now that the comet has moved past the Sun, telescopes on Earth can see it again. Comet 3I Atlas is important to us because it's only the third interstellar visitor we've ever seen, and it may be the biggest and oldest one yet. And it didn't break apart near the Sun like some other comets. By studying it, scientists can learn what materials exist in other star systems and better understand how comets, and even planets, form in our galaxy.
3, 2, 1, 0.
In 1977, NASA sent the Voyager spacecraft to explore the outer parts of the solar system and the space beyond. And at one point, the probes ran into something totally nightmarish: a blazing wall of fire measuring temperatures from 54,000 to 90,000 degrees Fahrenheit. Well, did the probes manage to survive these intense conditions? We'll find out soon. Meanwhile, there are several ways to think about where the solar system ends. One way is to say it ends where the planets stop. Another way is connected to the Oort cloud. That's a giant group of icy objects far beyond the planets, the farthest region of the solar system. It is extremely distant, maybe a quarter to halfway to the nearest star. To understand such huge distances, scientists often use something called the astronomical unit, or AU. 1 AU is the distance between Earth and the Sun. For comparison, Pluto orbits between about 30 to 50 AU from the Sun. The inner edge of the Oort cloud is thought to be much, much farther away, and the outer edge could be even further away. These distances are very hard to imagine. My little brain sputters when considering such. Now, we can also measure them in time instead of miles. NASA's Voyager 1 spacecraft makes almost 1 million miles per day. At that speed, it would take about 300 years to reach the Oort cloud, and maybe 30,000 years to reach its outer edge. Now, one more way to define the edge of the solar system is by the Sun's gravity. It might be the area where the Sun can still pull objects back toward it. And finally, we can define it by considering the heliopause, the boundary where the Sun's influence ends. You see, the Sun constantly sends out charged particles in a flow called the solar wind. This wind moves past all the planets and reaches about 3 times the distance to Pluto. The solar wind creates a giant bubble around the Sun and planets called the heliosphere. The heliopause is the outer edge of this bubble, where the solar wind meets the wind coming from other stars, called the interstellar wind. Here, the pressures from the solar wind and the interstellar wind balance each other. This causes the solar wind to turn back and flow along the tail of the heliosphere. As the heliosphere moves through space, it creates a bow shock, similar to the wave that forms in front of a ship moving through the water. So, depending on how you define it, by planets, by the Oort cloud, by gravity, or by the Sun's magnetic influence, the edge of the solar system can mean very different distances. But if we talk about the Voyagers, they came across something intense. It was something we could probably call a wall of fire. Blazing heat and intense temperatures. The 2 probes became the first spacecraft to travel beyond the heliosphere and cross the heliopause. Before the Voyager spacecraft reached the heliopause, scientists did not know exactly where this boundary would be. But the fact that the 2 spacecraft crossed it at different distances helped confirm some predictions about the heliopause. Scientists did expect that the edge of the heliosphere could move as the Sun's activity changes, a bit like a lung expanding and contracting as we breathe. And the fact that Voyager 1 and Voyager 2 encountered the heliopause at different distances matched this expectation. The heliopause is not a hard edge or solid wall, but the nickname Wall of Fire actually matches the nature of that insane region. Both spacecraft measured extremely high temperatures there, around 30,000 to 50,000 Kelvin, or 54,000 to 90,000 degrees Fahrenheit. Despite these extreme temperatures, the spacecraft were safe. The particles in this region are very far apart, so collisions are rare and not enough heat could reach the spacecraft to harm them. Nearly 50 years after their launch, Voyagers 1 and 2 continued to send back data from beyond the heliopause. They are the only 2 spacecraft that have crossed this boundary so far. Together, they have already made several curious discoveries about space outside the solar system. For example, Voyager 2's magnetic field measurements confirmed a surprising result from Voyager 1. Just beyond the heliopause, the magnetic field lines are aligned with the magnetic field inside the heliosphere. Before Voyager 2, scientists only had one measurement from Voyager 1, so they could not be sure whether this alignment was real or just a coincidence. Voyager 2 confirmed that the alignment was real. The magnetic fields inside and just outside the heliopause apparently run in parallel. These discoveries give scientists important information about the structure and behavior of space beyond the solar system. Now, let's dig a little deeper into the Voyager program itself. It's made up of 2 spacecraft, Voyager 1 and, wait for it, Voyager 2. Even though Voyager 2 was launched first in August 1977, Voyager 1 took off just 2 weeks later on a faster, more direct path. These 2 spacecraft have been traveling for more than 40 years, exploring worlds no human will ever walk on, at least in the near future. The 2 Voyager spacecraft are nearly identical. Each has a large radio dish that is 12 feet across. This dish sends data back to Earth. They also have 16 thrusters to control their direction and make sure the dishes always point toward our planet. The thrusters use special hydrazine fuel, and the spacecraft's electronics are powered by thermoelectric generators that run on plutonium. Each Voyager carries 11 scientific instruments. About half of them were made specifically to study planets, and most of those are now turned off. The turned-off instruments include several cameras, spectrometers, and 2 radio-based experiments. During their long journeys through the solar system, the Voyagers took tens of thousands of images and measurements. This data has changed what we know about the outer planets. When the Voyagers reached Jupiter, they gave us our first detailed look at the planet's atmosphere. They showed that the Great Red Spot was a huge storm spinning counterclockwise and interacting with smaller storms nearby. The Voyagers also discovered a faint dusty ring around Jupiter. They studied Jupiter's moons, too. They found volcanoes on Io, saw linear features on Europa that hinted at a hidden ocean beneath its icy surface, and confirmed that Ganymede is the largest moon in the solar system, larger even than Saturn's moon Titan. Next, the spacecraft flew past Saturn. They measured the planet's atmosphere and studied its famous rings, discovering gaps and waves we still see today. Voyager 1 looked through Titan's thick haze and suggested that the moon might have liquid hydrocarbons on its surface. It was later confirmed by other missions. Voyager 1 also found 3 new moons orbiting Saturn: Atlas, Prometheus, and Pandora. So that's where she ended up. After Saturn, Voyager 1 continued out of the solar system, while Voyager 2 headed toward Uranus. Voyager 2 discovered 11 new moons and 2 new rings there. It also observed strange features, such as Uranus's unusual magnetic field and a surprisingly small temperature difference between its equators and poles. Voyager 2's final planetary stop was Neptune. It happened 12 years after leaving Earth. There, it discovered 6 small moons and rings around the planet. It studied Neptune's atmosphere and magnetic field, and observed volcanic vents on Triton, Neptune's largest moon. After this, Voyager 2 joined Voyager 1 on its journey toward interstellar space. Voyager 1 entered interstellar space in August 2012, and Voyager 2 joined it in November 2018. These missions helped scientists measure the edge of our solar system, about 11 billion miles from the Sun. The spacecraft still sends back data about this mysterious region. By the way, after its planetary visits, Voyager 1 took the famous pale blue dot photo of Earth from about 3.7 billion miles away. Today, Voyager 1 is about 15.8 billion miles from Earth, and Voyager 2 is about 13.1 billion miles away. Each Voyager carries a golden record, a time capsule from Earth for other civilizations it might meet. The record covers include instructions for playing it, a map showing Earth's location, and a drawing of a hydrogen atom. The records are cleverly plated with uranium, so the decay of the uranium could help discoverers figure out when the record was made. The records contain 115 images showing Earth, humans, animals, plants, and our solar system. They include natural sounds like waves and birdsong, greetings in 55 languages, brainwave recordings, and a mix of music, ranging from Beethoven to Chuck Berry and folk songs.